Crack the Cambridge IGCSE Physics 2023 paper for Variant 2 with Orisheje Matthew's expert solutions to Question 8. So grab your pen, paper, and calculator, and let's get started. Welcome to Super Easy Physics and Mathematics, SEPAM.
Alright, so let's look at question 8. Question 8 is on nuclear physics and it has a total mark of 10. So let's see how you can comfortably get this mark, and also as you are preparing for your next exam. So let's look at it. Question 8. The isotope uranium-235 is represented by this symbol 23592 uranium. So when you are representing isotope, normally the general notation is atomic mass, then the mass number, atomic mass, then the symbol of the element. So in this case, the symbol of the element, which element? Uranium. 92 stands for the atomic number or number of proton, while this upper number here stands for the mass number or the nucleon number. So let's answer the question. Question 8a. State what the number 92 and 235 represent in this symbol. So the first one, 92, is the atomic number. Is the atomic number or is the proton number. So anyone you write is the number of proton in the nucleus. What does 235 represent? 235 is the mass number. Okay, mass number, or the numbers of nucleon number. So when we talk about nucleon number, we are talking about the numbers of nucleon. That is a nucleon number. So the nucleon number represents the total number of proton. So if you get this, the total number of proton plus total number of neutron in the nucleus of the atom. So in this case, you have how many? So let's see, how do you get the number of neutron? To get the number of neutron, all you need to do, you subtract this from the mass number, we give you the number of neutrons. So number of neutron is equal to mass number, take away atomic number Z. So which is equal to 235 take away 92. That will give me 143 neutron. Now, what is the implication? So let's see, I will explain this later. Now, let's go to question 8b. Uranium-235 is a fuel used in nuclear reactors. State the process by which energy is released from uranium-235 in a nuclear reactor. What is the process? So we are looking at this. Now, the process is what we call nuclear fission. Now, go. Okay, we said the process by which energy is released from the uranium is nuclear fission. So what is nuclear fission all about? So like this one, now this is the equation that represents a nuclear fission. So you have a big nucleus. So you have a big nuclide. Then you fired a neutron into it. Once it's bombarded with a neutron, then this big nucleus will now split into smaller nuclide. So it's split into xenon and strontium. So xenon 50, with the atomic number of 54 and strontium with the atomic number. So these are more stable nuclide. Now, describe the mass and energy alteration that take place during this process in the nuclear reactor. So we want to see the variation that took place here. Now, one thing I want you to know, take note when the questions are asked, it says describe the mass and energy. So what is the variation that take place in the mass of the nuclide and the energy that took place? So in nuclear fission, so first of all, let's look at the mass. Now, what happened is that in this particular question, in the nuclear reactor, uranium is converted to more stable, smaller total mass. So if you look at that, let me show you from the periodic table. Now the periodic table, you have your uranium here, and then if you look at the ratio of proton to neutron, here is 92 to 143. So it's very unstable because the ratio is more than 1. So here it split into xenon, so which is more stable. So the atomic number is 54, and xenon is a noble or inert gas. Then the second nuclide that was produced is strontium with the atomic number of 38. So which one? This one is alkaline earth metal, unreactive. This one xenon. So but this one is very reactive, which is an actinoid. So that is what happened to the mass. So the masses reduce. And then now let's look at the energy variation. So for us to look at the energy variation, what happened when uranium undergo nuclear fission? There's going to be the total mass of the product, xenon, the mass of xenon with the mass of strontium, plus the neutron that are released. When you add, the total mass will be smaller than the mass of the parent nuclide. So when you find the mass difference, is the mass difference that is now converted to thermal energy. So let's look at it. So energy difference, so you say the mass difference is converted to two things. A, thermal energy, which can be used for generation of electricity or even in nuclear warfare, atomic bomb. And then during the splitting process, the xenon and the strontium will fly away with a higher velocity. So we have kinetic energy of the product. So that is the energy change that takes place here. So now question 8C. Describe how thermal energy from nuclear reactions is used to generate electricity in power station. So I'm just going to show you the example of what happened in the power station. So I will just show you. So look at this. If you see this diagram here, so this is a diagram of a nuclear reactor. Here you put the fuel here, which is the nuclear fuel. In this case now, it is the uranium. So you put your uranium inside this reactor here, and then From here, when the reaction takes place, it's a chain reaction because it produces two neutrons. Okay, two neutrons are released during this reaction, and then this one will now collide with other unreacted nuclide, and then the reaction keep on increasing. So there is need to control the reaction using the control rod here, borons. Okay, when the thermal energy that is produced in the reaction is used to heat up water to produce steam, and then the steam is directed to a turbine, and in that turbine here, the steam pressurized in this container here is pressurized, and then the circulation goes to this turbine, and then the steam is used to rotate the blade of the electric generator, and then from here the generator to turn magnetic field using the principle of Lenz's law and then Michael Faraday's law of electromagnetism. So when the turbine turns the blade here, so EMF is induced, and then the EMF is directed to a transformer to step it up, then release into the national grid. Then what happens? The steam that is produced has to come to this point, you condense it so that you can recirculate it back, and then because it's very hot, you send it to the cooling tower where the cooling takes place here. And that's why you see that in a nuclear reactor, you always see steam coming out from the nuclear tower. So that is the cooling tower here. Then the cool water move to the condenser and come back again to this steam generator where the nuclear energy, the heat produced, is used to heat up the steam. So let's just put this one in a simple way that you can write in a simple way. So let's explain that. So what happened? Let's just put it in a simple step. So what happened in the nuclear reaction? We say that heat release from nuclear fission, okay, in the reactor are used to heat water to produce steam. Then next, this steam is used for driving turbine. Okay, the turbine are connected to generator. Okay, then the generator produce electricity, release to the national grid. So that is a process. Now, question 8CII. State one advantage and one disadvantage of using nuclear fuel in power station instead of using fossil fuel. So in this case, we are going to compare two ways of producing electricity using nuclear reactor and using your fossil fuel. So what is the advantage of using nuclear reactor over using fossil fuel? One advantage is that the small amount of nuclear fuel can produce more electricity, okay, when compared to the fusel fuel. So that is one advantage. Then it also has another advantage. Nuclear reactor does not pollute the air with carbon dioxide emission. So this other one, there are other advantages. Now let's look at the disadvantage. What is the disadvantage? The major disadvantage is that nuclear fuels produce toxic waste. So because of the leak, okay, if the leakage of nuclear something, that's why you see that in the nuclear reactor, it are kept inside confinement to prevent the radiation from escaping. But if this radiation escape is dangerous to human, so the leakage of radiation is dangerous. Then it has another disadvantage. What is the third disadvantage? Construction of nuclear reactor power station is very, very expensive compared to constructing a fusel fuel power station. So with terms of construction, cost of constructing nuclear power station is more expensive. Okay, so with that, we have the 10 mark to question 8.
And there you have it, a comprehensive solution to question 8 of the IGCSE Physics Paper 4, Variant 2, October-November 2023. Remember, practice makes perfect, so rewatch this video as many times as needed to solidify your understanding. For more expert guidance and solutions, stay tuned and watch videos on questions 1 to 9. Don't forget to like, comment, share, and subscribe to the Super Easy Physics and Mathematics channel for more helpful content. See you in the next video.